Aquatic venues are fun but complex systems. They're a delicate balance of lifeguards, water, sunscreen, pool treatment equipment, and chemicals. When the operation is running smoothly and effectively, the behind-the-scenes systems are rarely a thought, until they fail.
A malfunction is to blame for a chlorine leak after several people were sickened. Several ambulances were called around noon on Saturday after several people reported difficulty breathing.
And the effects can be serious.
We ended up transporting 35 patients away from the scene after decontaminating them. The sickest of them had difficulty breathing and were vomiting. The chemicals involved were muriatic acid and chlorine. There was an accident that occurred. Somehow the muriatic acid and chlorine undiluted got mixed together inside the pump room. It created a visible yellow cloud, and that drifted across the pool deck. What that can do is cause the lungs to start leaking fluid and fill the lungs up with that fluid, and you end up drowning in your own fluid.
Pools of all sizes are complex systems of pipes, pumps, filters, and injectors. Water must be clean, free of debris, and chemically treated to make it safe for swimmers. And it must be constantly flowing through the system in order for the treatment to work. Most times, minor problems pose no serious risk, like if the pH is slightly off or if there's minor debris in the pool. But when there's a problem with the critical process of circulation and chemical injection, the risk to swimmers can become life-threatening. Here's how it's supposed to work. Pool water is constantly circulated by a pump. The water is filtered, and a chlorine-based disinfectant and acid are added to make the pool water sanitary. As long as water continues to circulate, there is no cause for concern. In the incidents shown at the beginning of this program, something went wrong. Remember that the system is safe as long as water is circulating. If circulation stops, but the chemicals continue to be injected, serious problems can occur. Chlorine-based disinfectants and acid react to produce chlorine gas. When the circulation pump is off, and the chemical feeders continue to pump, dangerous levels of chlorine gas can build up in the pipes. When circulation resumes, the gas is pushed out of the pipes and into the pool, endangering people in and around the pool. To protect people, chemical feeders should automatically shut off when there's no water flow in the circulation system at the point of chemical injection. In order for this automatic shutdown to work, all components should be electrically interlocked together so they function as one system. There are essentially two ways to electrically interlock a system, either conceptually through circuit breaker design or directly through the use of a master electrical interlock box, also referred to as a safety switch. It's important to note that basic interlock designs only react to electrical incidents, such as loss of power, and not to an inherent loss of flow, which might be caused by something else. The basic level of interlock protection is to ensure electrical connections to the circulation pump and the chemical controller or feeders are on the same circuit. If the circuit powering the pump is tripped, power to the chemical feeders is also lost and chlorine-based disinfectants and acid will not be injected. A more advanced level of interlock protection would be to incorporate a flow or float switch in the sample stream of the chemical controller. When the sample stream loses flow, the switch signals the controller to stop the chemical feed. However, this method is dependent upon where the sample stream is installed in the circulation system. The highest level of protection is to incorporate an interlock box or safety switch that monitors and controls the circulation pump and the chemical feeders from the point of injection. The individual components are truly interlocked or dependent upon each other for proper operation. For example, if the circulation pump stops, the interlock automatically shuts the chemical feeders down. So if these systems are designed to protect people in the event of a failure, why do people get hurt? The answer is simple. mechanical failure, or human factors. A flow switch could fail and send a false indication of water flow when there is none, and the chemical injectors would still feed chlorine disinfectant and acid into the system. Additionally, a maintenance operator can bypass these safety methods by plugging the chemical feeders into another circuit. As shown in this video, many incidents occur as a result of human error that led to a situation that endangered swimmers. These incidents arise not out of maliciousness, but from a desire to keep the pool open. Unfortunately, they may have acted without an understanding of the consequences of their actions. The more barriers in place, the less likely all are able to fail or be bypassed at the same time. First and foremost, the aquatic venue should be closed and all bathers removed from the pool and deck anytime there is maintenance work to be performed on the circulation and chemical systems. The pool and deck area should be cleared immediately anytime a flow sensor detects no flow in the system, or when there is an unexpected or manual deactivation of the circulation pump, or when the interlock system is activated, indicating a problem with the flow system. Bathers should not be allowed back into the aquatic venue until the cause of the interruption is understood and the condition is corrected. The system should operate correctly for at least 5 minutes and the water tested to ensure proper pH and free chlorine levels before allowing bathers into the pool and deck areas. The circulation and chemical feeder system, as well as the electrical interlock system, should be working properly. The safety switch system and the electrical interlock should be installed and maintained according to the manufacturer's instructions. It should not be modified or bypassed in any way. You should not use an alternate source of electrical power to the feeders. This defeats the purpose of the interlock. An alarm or other indicator should be activated whenever the chemical feeder is disabled through the safety switch or electrical interlock system to alert staff to evacuate the pool area. An initial challenge test should be conducted upon installation of the system, and regular challenge tests, including a backwash cycle at least once a month, should be conducted to ensure the proper operation of the interlock system, safety switch, sensors, and alarms. There should be proper labeling of all components, including tanks, feeders, pipes, and direction of flow. Keep all signs, labels, and placards up to date and legible. Consider using safety signs as reminders to take actions, such as evacuate the pool area under certain conditions. Staff should be trained on recognizing high-risk scenarios that could lead to chlorine gas exposure, including when circulation ceases and when the electrical interlock and safety switch failure alert system is activated. It's best to prevent emergencies before they happen. OSHA hazard communication plan requirements should be followed, including developing an emergency action plan. Aquatic venues of all sizes are complex systems, but with a few precautions and adherence to critical safety measures, they can be extremely fun and safe.
Pretty far away, and we've seen scenarios where the pumps stop and if a check valve has failed or is not in the right location, you might get a little bit of flow temporarily while it kind of drains out, or it might even back siphon, and then it can trick these sensors that, hey, there's still flow going on even though the pump is turned off. But the flow would be low enough that it could still be a problem. Those are kind of the three main ways that you can interlock. Any questions about that? before I can show you a couple of products that are on the market right now. Let's see, I assume there'll be notes. Somebody's asking if there's going to be notes to this meeting. I'll let you answer that. Okay. Let me pull up. So we'll start with the pressure switch. So there's this is a trend across the whole country. We do work all over the country, and Utah is actually one of the first states to jump on this and codify it. But it's an issue everywhere, and it's a hot issue everywhere. So there's been products being developed across the country that deal with this. So the first is the pressure switch type. So let's see. It's not my normal. Sorry, this is not my normal program I use, so I'm having a hard time there. Maybe that's it. Okay. Hopefully that's, let me share and see if that's big enough for you all. Okay, so this is a product that is out on the market currently to address this. And it's a pressure switch, so it's the second type we talked about. And it's sold by IPS, which that's a chemical controller company. You've probably seen those, at least you see them on some facilities, I'm sure. It's a popular one. So how this one works is, I should zoom in. So it's showing an example of your flow cell and the water that would already be coming through here. And then you would also have your paddle wheel or your float or something kind of built into this already. And then this is the second device that is added. And it basically adds to that tubing. This device plugs straight into the wall. And then if you have a chemical controller that has its own plug that you plug in, then that plugs into this, well, not pigtail, but the female adapter right here. And and basically it becomes in line. So it'll actually cut power to completely to the controller, okay? And if there's no power to the controller, on most controllers, it will not feed chemicals. There are some exceptions to that, and I'll tell you, let's talk about that. So some of the higher end controllers that have a lot of features that people like also have a separate relay built into them for their chemical feeders. So you can have power to your unit and not have power to your chemical feeders, and vice versa. You can have power to your chemical feeders and not have power to your unit. And those kind are usually hardwired in place. They don't have a plug that you plug into a receptacle, okay? That would be probably a good indicator of whether you have the kind that has separate power to the relays versus to the controller that controls it all. Most of your, I'd say that probably most of you will have the kind that plugs right into something. So this would be a good solution for those of you who have that. If you don't have this and you have the kind of controller that has separate power to the relays, and a couple of brands that come to mind that are popular is Chemtrol makes some like that, Bex. You get to the Bex System 5 and above, and there's a lot of those around this area. Those would have separate power, and maybe some Prominent controllers as well would have that. So that's something you would need to check on with what you have at your facility, and see if this would be an option for you, okay? Yeah.
Got a question. How can we integrate a flow switch or pressure switch to interrupt power to chemical controllers or feeders that work on 115 volt AC. Most pressure switches and flow sensors are low voltage.
Okay. So this one I have up here is a 115. So that's a standard 115 plug, and maybe they're talking about on the relay side potentially. And something like this would be more difficult to do, and you would either need a power monitor or a true electrical interlock for those kinds. So you would need to basically have your, sometimes there's a contactor on the pump that you basically do control wiring, and you can have a relay and a contactor. And so when there's power loss to the pump, it opens the relay and cuts power. Even if it's 120, it will cut power to the pumps. I don't know if that answered it, but that's where no one of these is a solve all for everyone. And so that's, I think, where probably the biggest take home for you is to figure out what you have and which one's going to be the best for you. Then let's see here. So one thing this is kind of a little bit off topic, but one thing that the code doesn't address is if you have an erosion type chemical feeder and you don't have a chemical controller. Do any of you here have pools that don't have chemical controllers? At least for those of you in the room. Everyone has a chemical controller. I think around here most people do, but I still come across some here and there that don't. Where they're putting a tablet into a feeder and then just flowing water through the feeder. And this language really doesn't address that. And that's going to probably be a challenge for you as the health department too on how to do that. So long as they have proper check valves and backflow prevention and things like that, then the way those even function in the first place is based on flow. So without flow, there's no erosion. So the need for this is reduced because of that. But there are some scenarios where people are also where they do have a chemical feeder, but there's also a complicated enough system to where you get worried about siphoning and some of those things I was mentioning earlier that have caused some of the problems. In fact, one of the recent problems here in Utah was a scenario where the electrical interlock actually worked, but they weren't using the kind of chemical feeder that's with pressure is injecting the chemicals in. They're using a Venturi type, to where as the water flows past the chemical feeder, it creates a vacuum and it pulls the chemicals in. And a lot of big facilities, this was a really big facility, and a lot of big facilities do that because they can add more chemicals quicker that way. And what happened is they had, like I say, they had elevation differences, and they started siphoning, and chemicals just kept going through there even though there was no flow. And then when they turn the pump back on, it sends a blast of chlorine gas to the pool. So yeah.
Okay, we got another question. Does the code remain the same if you have CO2 system for lowering the pH instead of acid?
Yes. Yes. Any chemicals, well, actually, that's a really good question, because I think it really is talking about, yes, it would cover both the chlorine and the pH control, whether it's acid, CO2, etc. Even maybe what they're getting at is, hey, if you don't have acid and chlorine mixing and creating this problem, having CO2 build up in your pipes. Is that a problem? And I think the answer is yes, it's still a problem. You may not create the same problem as you would if it was acid and chlorine, but CO2 has a lot of safety controls to it as well. So the way that's written, the answer is yes. You have to do that. Okay. Okay, let's go to the next one. There's a third one made locally here too that but we don't have much information on it because the company that makes it is also a pool service company, and they really will only, they're not selling it as a product, so it's only if they do your installation for you. There is a third one that I can't speak to, but there's this one, and this one is the power monitor method. And this one actually has flexibility where you could use a pressure switch, you could use a power monitor. There's a lot of flexibility in this one. This one has a lot of bells and whistles to it. Let me zoom in on that a little bit closer. So Bex, I talked about a Bex controller. This is the same company, yet they sell this as an independent product. So it's called the Interlock system. And what they've done for helping you as the operators and also as the health department to verify that it's working is they've put lights and alarms and shutoffs on it so that you can see, you can basically verify that it's working. So if I go to the next page, maybe. This one can control up to four feeders. So this is the kind that wouldn't necessarily cut off power to your chemical controller. This is the kind that it basically, and I'll pull up a data sheet here, but this one would sense power to the pump or pressure or whatnot. And the box has all the interlocks tied to it. So there's control wiring from your pumps, from your VFDs, et cetera, into this box. And then when it senses no power, it opens the circuit and doesn't allow power to go to any of your feeders. Okay, so this is also called an interlock box, is another way, whereas that other one they were calling it a control box, where it just turns it on and off. Pull up the other one. Let's see. For you technical people, be able to see this. Okay. Yeah. So kind of here's the concept. You basically have a transformer with some dry contacts that you're tying to your system, and then it in turn opens up these relays and won't allow the power to go to your feeder by opening that interlock relay right there. Okay. So this is a little more complicated. This requires some control wiring and whatnot. Most of that's in the box, but you do have to tie it to your pumps and your chemical system to help control it. And then, of course, and then I guess the third way, well, let me show you the electrical diagram. Shows the light. So whenever it's tripped, it'll basically have an alarm light that comes on. And it's got external control relays here. Let me teach you your. So anyway, if you understand electrical, that diagram probably makes sense to you. You may not be one of those people. Okay, so that is, those are a couple of like off-the-shelf products that you could consider to do this. The code does open it up to where you can just have a capable person contractor who knows how to do this themselves, could create an electrical interlock. as well. So, you really have, and like I say, many of you probably already have an electrical interlock unless there's been changes to your system that you may already be compliant. You just need to find that out and verify that. Okay, any questions? This is kind of technical stuff, so hopefully that made sense. That video, to me, is one of the makes it the most make the most sense. John, that's just a video you could find, or I could share with you, and people want it to rewatch that because there's a lot in there actually when you watch the first time you don't catch. So.
Yeah, absolutely share that, and we'd love to share that with anyone interested. I got a question. Sometimes for me, the need and seriousness of it hits home a little more when something's local. You mentioned there were maybe a high profile one or two locally. I don't know about details or anything, but do you mind sharing maybe what was there an incident or two that kind of really pushed the code here in Utah?
Yeah, there was. There was a rec center I think it was actually an outdoor community pool that had, they were using the Venturi feeder with a booster pump to pull the chemicals in. And even though things shut off, my understanding is it continued to siphon. So they're basically pulling from a big bulk tank. And even though flow stopped, the chemicals were in motion when it stopped. So it created a siphon. So picture like siphoning gas out of your tank. Once you have that flow going, it was able to just siphon. And so, so that's one. There was also a water park a couple of years ago too that had one. I think some of them are done. Some of them are because of delivery and the way there's like an accident as they're setting it up or delivering it. And then there was one a few years back, also a city pool that, and this is probably a good thing to talk about because some of you would probably like this, but it's a bigger facility. They have 3-phase pumps, and when you have a power outage with a 3-phase pump, you have to manually restart those often. And so unless you have a VFD or some sort of controls that would bring it back online. Well, that was their case. So they had a flow switch in their chemical controller failed. There was a power outage and they didn't know it. And it was like, I think it was like I can't remember the exact timing, but I want to say it was somewhere between 15 minutes, 45 minutes where the chemicals still thought they should be feeding because the sensor was saying there was a call for demand because it wasn't getting pool water past it that had chemicals in it. So and the flow switch was not working to cut it off. So it's sitting there just pumping chemicals for this duration of time. And then the operator realizes, oh, we don't have any flow going on here. We've had a power outage. They go back in and turn on the pump. And at that point, they'd already created the plume of gas. And this was a rural Utah city, and it just sent this shock of chlorine and sent kids to the hospital. I'm not aware of any deaths, but definitely there's been accidents where people have had to go get treatment. So that's all I'll say. I don't. You can probably Google news stories and find them. Any other questions? I think if any of you have a newer facility in particular, you'll want to check also to see if you have it. I know there's a lot of contractors who won't put in a pool unless it has it now, just because they know the code's coming. And there are other health departments that are wanting to see it on new construction. I'm not sure they can require it, but they can encourage it at least. So you may already have one of these interlock devices on. I mean, they've been out for about a year now, and we've seen them. I've gone into a lot of equipment rooms and didn't even know, but they've added them, you know, so. Any more questions about the interlocking? You want me to talk about VGB just for a quick second? Okay, so I mean, we all remember, if you've been in the pool business for the past 12 years, you probably remember VGBA #1, where every public pool in the United States had to put in new main drains, new covers, and make sure that you either had a vacuum safety device or double main drains or a gravity flow system or an unblockable drain. So back then, when they came out with this standard, it was all done really quickly because of a high profile drowning that had occurred from suction entrapment. It was a senator's grandchild who got killed. And so they, you know, this law went into effect fast and furious. It was a mess. I don't know if any of you were around for that, but it took a long time for the Justice Department to even really explain the law and what needed to happen, even though everyone was supposed to already be compliant. So they worked through it, and they had set up a testing standard for drain manufacturers. And so drain manufacturers had to take their fittings, and they had to send them through a battery of tests. And those tests included, I think there's 5 of them. There's suction entrapment, like body entrapment. There's limb entrapment. There's mechanical entrapment. So somebody with a ring or a necklace or something on them that gets mechanically caught in the drain. And hair entanglement is the other big one. And evisceration might have been the 5th one. So anyway, they had to kind of do tests to show that their covers met this, which they all did. Oh, the other one was a durability standard. That was it. So they would do they had to expose their drains to like a simulated increased UV exposure. And then they were required to label their drains with a certain date on them, a time frame that they would be safe for. And then when that expires, it basically became an expiration date for your drains. And when those expired, you need to replace those. Okay. So that's kind of where we've been for the last 12 years. So then in 2019, and it went in effect, I think in 2021, they kept delaying it, but they found some problems with their testing standards. And so, and most of it pertained to hair entanglement. And so they increased their testing criteria for hair entanglement on these main drains. And now, and this law was written in 2017 to make the change, but like I say, just barely went into effect here recently. And so cover manufacturers are having to scramble and get all of their covers retested now. And some have done it and some are still working on it. And so there's a really, really limited amount of covers available for VGB. It's called VGB 17 standard. And one of the byproducts of this testing is that the covers, many of them, their flow ratings went way down. And the ones in particular that we saw the biggest impact in are like the channel drains, which are really popular. We love them for a lot of reasons. If you have a channel drain, you know, the new channel drains now have a much lower flow rating on them. So what your challenge is the way the law is written is if your cover met the original VGB and it's not expired, you're fine until you need to replace that. And then when you need to replace that, you would need to, theoretically, there should only be available new covers that are rated or certified to the new standard. But it's going to cause a headache for everyone, including us. I mean, people spent all this money updating their pools based on a standard in 08, 09, and now the way those were done, you're not going to be able to find a cover that has the flow rating you need. I mean, most people will probably, they'll be able to find a plug and play that will work, but some of you won't. They're getting really picky about how the pipes connect to the drain. The days of doing a field built sump are getting reduced because every manufacturer is required to get all scenarios of piping and cover and sump depth underneath the cover all tested in combination for this hair entanglement. Because that was the problem, is that the cover wouldn't cause the problem, but the hair, it's like 16 inches of hair. So the hair would go down and it would wrap around a fitting or an elbow or something. And so they've changed the whole nomenclature to this, to a suction outlet fitting assembly, and also known as a SOFA. And a SOFA basically encompasses the cover, the grate, the sump, and in some cases, an extension of the piping for some distance beyond that sump. And that's what's complicated this whole thing. And it's still, I mean, it's still a mess, and it's going to take a minute for these manufacturers to get enough stuff tested for you. So hopefully manufacturers can still sell old product until it's expired. So if you think your main drains are coming up for expiration, you might want to catch some of those before before they're sold out, if you can find some. And then that would buy you time being compliant until the manufacturers get up to speed with all the different combinations of testing. So sorry to be bearers of bad news, but that's kind of what the new VGB is all about, and probably why you're adding an emphasis to it, is because there's basically a new standard out there. And those standards, so the first one is the ANSI -7 2020 standard. And this one talks more about, this is called suction entrapment avoidance in swimming pools, wading pools, spas, hot tubs, and catch basins. So this kind of talks about the design of the system, you know, and how it interacts with your pool. And then this standard it basically says that all of your SOFAs, or your suction outlet fitting assemblies here, have to meet this new updated standard from 2017. And this is the standard that is now, you know, has enhanced hair testing. It's requiring, you know, more scrutiny on sumps and piping configurations and testing of all of that stuff. So these are the two standards that have changed. And be aware of that. If you want to go to sleep at night, you could order them and read them, because it's just code talk. But that's what's driving all of that. And yeah, and I know some, you know, every manufacturer back in the original VGB was required to label on the drain cover, like it had to meet the original standard. And then they were supposed to give you some way to track the time on it. Some manufacturers have a little dot on their drains that are a different color, and you know by the color whether it's expired or not. You have to go to their website and see, like, oh, if it's, you know, if it's green, then that's no longer valid or whatever. Others, you're just going to have to probably go back and find your paperwork from the first time you did it, if your facility's that old. And if you have a facility that was built somewhere between 2009 and now, your covers will be compliant with that new standard, and you probably are in a better shape for your drain configuration too, just because it would have been designed to the new codes for all of that that hit originally. So anyway, any questions on that?
How many years is a drain cover good for?
The manufacturer has to do that UV testing, and they have to determine that. They have to pass the test, and they can do accelerated testing to predict how long it'll last. I think there's 5-year, 7-year, and 10-year are the 3 common ones I see. I'd say probably most of the smaller pools, the smaller stuff, are 5 or 7-year. Kind of the nature of plastic is.
So that would be the same as far as knowing like when the cover was made or the expiration date. The same for how long it's good for is going to be based on the manufacturer themselves, and they kind of need to research that or talk to the manufacturer of the drain cover.
That's true, but there is a caveat. So the code, the requirement does say that the clock doesn't start counting until you take it out of its package, because it's really until it's exposed, really until it's installed and exposed to potentially UV or light or whatever, chemicals, the chemicals from the pool, all those things. That's when the clock is supposed to start. So hopefully you have paperwork for your pool of when you put those in. That would be your best indicator of that. Is there another question here? Okay. Any more questions? Okay.
I just want to reiterate, we are very thankful to work with all of you, and you guys do great work. And we just want to make sure, that, the lines of communication are open, and please reach out any questions that you have. And, if we don't have the answer, we would love to forward you to those who do, like Tom, who is many, many years of experience, or other professionals. So if you have questions, please reach out. And I just want to say thank you to all of you attending in person, online, and who might watch it later. Thank you for your work in keeping the pools safe and open for recreation. So with that, I'd like to close the meeting and just say thank you.
It's good, isn't it?